All right, so what we're going to do in this session is we're just going to do a survey of some of the open source Java projects, or let's just say big data projects, because if you haven't seen how many there are just at the Apache Foundation, there's like a lot of them, right? So the idea is to, within about 35 minutes, get through some of them, give you an idea of what they do. And if you have questions, this is only about a 30 or 35-minute session, so please ask questions. That would be great. I know it's the end of the day and everyone's running low on caffeine. It's almost time to hit the bar, et cetera, et cetera. But please ask some questions. Be happy to answer what I can. So my name is Pratik Patel. I'm a Java champion. I'm based out of Atlanta, and I currently work at a company called Azul Systems. And we make what we think is the best JVM in the galaxy, which is especially well suited for big data projects which run on Java. And we also make an open source build of OpenJDK, which is completely free. And then the Platform Prime is the JDK that I mentioned that is great at running big data projects of all kinds. So for example, if you look at the Java Renaissance test suite, Azul Platform Prime outperforms standard OpenJDK by 37%. It's because of its low latency garbage collector, among other things. And of course, it's a JDK, so you don't have to change any code. You can literally drop it in and run any Java project on it. Okay. And one more thing, if you haven't seen this is a community website that a bunch of folks I've been working on for a while. It's called FUJ, or Friends of OpenJDK. And there's all sorts of great content on not just big data, but like Java in the cloud and Java in Cube and other things like that. So it's worth checking out. You can publish something yourself if you like. It's totally community run. All right. So what I want to do is I want to spend a little bit of time talking about what big data is, because I think there's a lot of confusion out there, because big data is kind of a big umbrella term. But what does it actually mean, right? What are some of the key things if you're working on a project at work and you're not using an off-the-shelf tool like this, and someone says, hey, is that a big data project? Hopefully after these few slides, you'll understand. And we'll talk also for a few minutes about why Java is well suited for big data projects. And then of course, we'll go into and look at some open source big data projects also. Okay, so let's start with what is big data, right? In a nutshell, big data is data processing at scale, right? The scale part is what's important with this. And what that specifically means is these are the three original things that define big data. They've added more, which we'll get to in just a second, right? But volume, velocity, and variety. Volume, that makes sense to everybody, right? Huge amount of data. Velocity means how fast is the data coming in? Is the data at rest for any period of time, right? How often does the data change? And then variety means what is the shape of the data itself? Is everything just like an object that has like, maybe 10 or 50 fields in it and it's fairly static? Or does it have variety, different types of data? You may have an object that contains 50 things, or you may have a nested set of objects that you use for doing different kinds of processing. Maybe you have objects that are continuously coming in, which represent GPS data, right? So it's the variety of different things also that can help you understand if you are building a big data project or not. Right. And then these are some of the newer ones. Exhaustivity, data is fine-grained. Relationality. Relationality is that that there are relations between the different types of data that you have, right? So again, these are different ways that you can quantify and determine if you have a big data project. Okay, some more. Extensionality, right? Can you extend the data that you have? Can you extend the system that you have? Veracity means, is the data true? And then of course, the value and variability of the data itself. Okay, and I know I went through that really quickly. So if you go to this URL here, which I think we're going to publish the slides, you can see that there is a more detailed explanation of all those 12 different factors. Well, I don't think it's 12, but you can see how many there are here, right? All of these different factors. So it will help you understand, again, what is big data? And like, when we talk to management or to our team, how do we think of this as a big data project or not? Okay. All right. So some of the other metrics that I use to quantify something as big data is, do you have multiple servers that need to be used to process and or store the data. If you can just run everything on a single server and or like your laptop or something, it's probably not a big data project. But if you're doing distributed processing and again at scale, then you have big data. And of course, with all these tools that we're going to talk about, you can test everything on your laptop, and then you can go and deploy onto your own data center cluster or somewhere into the cloud or whatever you want to do, right? I know a lot of people, what they do is they will load up Apache Spark data from HDFS into, for example, an AWS very large instance, do some data processing, and then basically shut it down because they just don't need to run it all the time, right? So that is still a big data project, even if you're not running it all the time. Okay, but I'll show you a tool actually that's really useful for doing that, called Apache Zeppelin, to help you essentially do some experimentation and some initial prototyping without having to write a lot of code in kind of an interactive way. But we'll get to that in just a minute. All right, so let's switch gears for a second and talk about why does big data run on Java, right? Why are all these Apache projects, well, not all of them, but almost all of them, why are they all written in Java, right? And how many non-Java developers are in here, out of curiosity? So everyone in here is a Java dev, except for one person, a couple of folks. Okay. All right. So for those of you folks who are Java devs, you will probably recognize all these different things, right? Oh, let's go back. Sorry, I skipped ahead too fast. All right. So why does big data run on Java? Why are all these projects like Spark and Hadoop and et cetera written in Java? Well, Java is fast because of the industry leading Java virtual machine. JVM is by far the fastest virtual machine that's available, faster than Chrome's V8 JavaScript, for example. And of course, if you work with Python, you know that Python is not as fast as Java for doing volume-based data processing, right? That's just the nature of the language and the platform. But Java, very, very fast, and you don't have to write C. That's the important part, right? Nobody wants to do memory management anymore, right? Also, Java is open source because of OpenJDK, and that also means that this entire constellation of tools that we use for big data are built on a foundation of something that is open source. So we have open source all the way from the JVM up into the tool, whether you're talking about Apache Flink or Spark or whatever. All right, and again, Java folks in the room know this. Java is easier to program than C because it's a garbage collected platform. You don't have to do low-level memory management, and that has some trade-offs, of course. You don't necessarily get the raw horsepower that you would get with C, but in some cases, because of Java's JIT and the way it can do memory allocation and deallocation and garbage collection, you can actually get, well, and also code level optimization that happens after the JVM has started up and has started running your code or running your big data project. It continuously optimizes and finds faster paths for your code to run. So this may come as a surprise to some folks, but running something on the JVM can actually be faster than writing something with C because of that continuous optimization that the JVM can do. Okay, so another reason why Java is good for big data projects. So why are all the big data projects at the Apache Foundation? This is a question that I do not have an answer to. I think it may have just been some kind of historical thing where, of course, not all the big data projects are at ASF, but it seems like almost all of them are, right? And we'll look at some in just a minute. So, and we are going to focus on the Apache projects, and we're not going to talk about Elastic and other things like that in here, even though actually Elastic also runs on Java, Elasticsearch at least. Sorry. So these are just some of the projects. We are not going to go through all of these because it would take way too long to do that. And you can see that some of these are also been retired, which means that in the attic, for example. But let's have a look at a few of these and let's see which ones are interesting. Now, Apache Cassandra, most of you probably heard of. It is not technically a big data project. It's more like a big data object store. That's how I describe it, right? So technically, it's not categorized, if you go here, under the big data category on Apache's website, but it is oftentimes the foundation for big data projects. So let's see what it does. Okay, so Cassandra is essentially a wide column store, right? So what you have is you have two-dimensional key values, keys and values inside of this store. And the reason why it's the foundation for a lot of big data projects is because it does automatic, no, mostly automatic sharding and data partitioning for you. So that means you can store a huge amount of data inside of Cassandra. And even as you add more data to the store, as long as you scale it out with the appropriate number of servers, it will shard the data for you. And it gives you near real-time performance for both insertion and for queries. So this is why it's the kind of the backbone for a lot of big data projects, where people build their own big data projects on top of Cassandra, right? And it is a NoSQL type data store. When I gave this presentation last time, someone asked, how does it compare to MongoDB? And I don't know how to answer that question because I haven't used MongoDB enough to, give it, be fair about it. Okay. So anyways, NoSQL supports sharding, data partitioning. As you add more and more data to it, it does not slow down. That's one of the key kind of benefits with Cassandra. So that's what the linear scalability means in that, right? So that means, some systems, as you add more data or you do more processing, instead of the processing time being flat, it kind of processing time goes up, which means that it's basically not completely linear, right? But you can add servers and it has nice fault tolerance also. So that means when you're using Cassandra, you can actually do replication across different data centers or different regions. So if a region goes down, it can automatically fail over to another region and you don't lose any, basically your system never goes down. So that's the fault tolerance part of this, right? So Cassandra handles that data replication automatically. And it's been around for a really long time, right? So it has, again, excellent read and write capability, or very fast read and write capability. So one thing to remember about Cassandra, though, is if you're using Postgres or using Oracle Database Server or MySQL or whatever, you're used to this idea of relations, right? Cassandra does not have that same concept of relations. And also, columns can vary from row to row. So that means that if you're used to a database, for example, you have a very rigid kind of column structure that you create or table structure you create. Whereas with Cassandra, you can have something that's very wide and you can have data that doesn't necessarily appear in every row. So you can have that variability that we were talking about earlier when we were describing big data projects. So you can have data that is not necessarily exactly the same from row to row. And the reason why this is important is because it gives you that variability and also flexibility that you don't have a very rigid data model as you're working with Cassandra, right? And this is key for lots of big data projects. So let's just have a look at some quick code here. If you look at this, you might say, well, this actually looks a lot like SQL, and it does, right? So create a table. And again, all the things have a reference link that you can go and like kind of examine further if you like. So, right, so we've created a table here. We've set a primary key. Now, how do we go and put something in it? Again, looks a lot like SQL, insert into, et cetera, these different things into that data structure. Okay. All right. So now let's switch gears and talk about Apache Spark. I think everybody has heard of Spark, so I'm not going to spend a huge amount of time on this, but I'd like to explain a few things that I've found while working with Spark. I've built out several Spark projects before, and it's one of my favorite frameworks because it's just the raw throughput that I can get with Apache Spark. Okay. So some people describe it as a unified analytics engine. So it allows you to do at scale processing and analysis of data. Okay, so what does that mean though, right? Oh, well, before we get to that part, the other interesting thing about Spark is that you can write code in Java. Most people, well, maybe not most people, a lot of people write Spark code using Scala. And there's been a recent addition of a library that allows you to also use Kotlin. So in case you're interested in Kotlin. And what's also interesting is you can also write stuff using Python. Okay, so you're not necessarily limited by what you can do. So when I think of Spark, there are three major areas that Spark is useful for. first is stream processing. You can stream loads of data into a Spark engine, and you can do manipulation or transformation of that data in almost near real time. A lot of people also use it as a basis for machine learning types of things, right? We'll look at that a little bit in just a second. And of course, with Spark, you can do graph analysis with this because everything is represented essentially as objects, or let's say Java objects to simplify it a little bit. So you have an object tree and you can do direct analysis against a very, very, very large graph heap that you store in memory. Okay. And so when I say large, I mean on the order of gigabytes, tens of gigabytes or more that you basically store in memory. Okay. Now, someone mentioned Hadoop. Not a lot of people use Hadoop anymore because Spark is 100 times faster. And the main reason why Spark is so much faster is because it runs in memory and not on disk. Okay. And also Hadoop uses more of a MapReduce type of approach to partitioning and processing and analyzing its data, whereas Spark is more of a graph-based processing model. Okay. If for those of you who are Java devs, when you build out a object graph or object tree, right? Let's say you have an organization or company object. That company object contains a list of persons. That person object, each person object will contain a sub object, which will have their address in it, for example. What we're doing is we're creating an object graph here, and Spark can operate directly against the object graph. Okay, so you're not necessarily limited by the way that the data actually looks, because as Java developers, or even if you don't build Java devs, if you've ever worked in an object-oriented language, you have built out graph data structures before, right? Definitely. Okay, so of course, with everything running in memory, you need to have a lot of memory, right? Thankfully, you can rent memory very cheaply nowadays. The price of memory hasn't really gone down much in the last 5 years, but it's still relatively inexpensive to get enterprise-grade memory even today, right? So I think the last time I looked, if you were just to go out and purchase ECC DRAM and the fastest speed available, it typically is somewhere around $200 for 32 gigabytes of ECC memory, right? If you go down to your local electronics store and get something for like your PC, that's non-ECC memory or error correcting memory. So ECC memory is a little bit more expensive, right? Typically, I think 32 gigs now is like $120 for like standard PC grade, but enterprise grade memory is about $200 for 32 if you're going to buy it. Of course, if you're renting it on Amazon or you're renting it on Microsoft Azure, there's obviously a cost associated with it. So you have to be cognizant of that, I think. But memory is not as expensive as it used to be, thankfully. So, all right. Now, one of the other things that I'd like to mention about Spark is that once you have this data inside of a Spark cluster, you can very easily parallelize it. That means you can run stuff in parallel to get almost real-time analytics or data transformation out of it, which is really, really nice, right? So Spark, with a few hints, will parallelize the data for you, right? Or the processing, I should say, for you, right? So let's see what that looks like really quickly. We have there's something called an RDD, which is a specific data structure that Spark uses. And you can see on the first line here that it says, go and read a text file from HDFS. So HDFS is the Hadoop file system. So actually you can take, if you're already using Hadoop, you can take that Hadoop file system data that you already have, and you can actually import it directly into a Spark cluster, right? It supports lots of other things, CSV, this and that. Like there's loads of different ways that you can pull data into and export data from Spark, but ironically, it can also just use HDFS. So what this is doing is this is creating a tuple called a Java pair RDD. And then what this code does is it runs a flat map, it maps the pairs, and then it does a reduce against it. And what all that means is it's basically counting all the words which are in the file. Okay, that's all this code does. But this code parallelizable, right? So you can import a very, 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 very large file. Once it's in memory, it'll run like this because it can be parallelized. It will go and kind of split everything for you into a cluster-based view. Okay, so if we look at how we can explicitly do it, you can see at the top line, we say go parallelize these specific things. Again, we have our RDD, which is the base data structure for Spark. And then at the bottom, we're just running some stats against it. What's the mean? What's the variance? What are the number of things which are non-zero in this array of numbers or vector of numbers? Okay. Again, the URLs are here at the bottom. All right, so let's move swiftly on and talk about Apache Kafka. Now, Kafka is something that has been very popular, as everybody in this room knows, over the last few years. And again, what I want to do is highlight some things so that maybe you learn something that you don't already know about Kafka if you're not using it, or even if you are using it. Okay, so one of the ways I like to think about Kafka is that it's similar to JMS, or Java Message Service, or more generally speaking, MQs or message queues, but it has very different semantics in terms of the way that you think of pushing messages or pulling messages even within a Kafka-based system. And one of the other key differences compared to MQs and to JMS is that Kafka is super scalable. MQs are very scalable, but they kind of break down when you start going into the millions of messages per second area, right? So most MQs can handle, let's say, millions of messages across a cluster. But when you start going from there to 10 million, 100 million messages a second or whatever, that's when traditional MQs start to show their age a little bit. And that's where Kafka comes in, because it's more of an event stream platform rather than a message queue type of platform. Right. So you probably have seen this before, so I won't talk about this too much. Kafka has this concept of a producer and writer, which, again, if you've used an MQ before, you're familiar with. And what it does is internally, it can partition the data for you with some configuration so that it does have that scalability, and you can get different things like ordering and other things like that within the Kafka architecture. One thing I should note is that in the latest version of Kafka, they no longer use Zookeeper to go and do the coordination between the cluster. They basically built something else to do it now. Okay. Right. I mentioned this before. Kafka is an event streaming platform, not so much a message queue platform. So let's look at a little bit of an architecture diagram. So this is a nice diagram because in a lot of ways it shows how Kafka can fit into an overall big data type of architecture. So you have Kafka in the middle, you have your events or your data in motion coming in from the bottom, right? So different kinds of logs, metrics, transaction data, IoT data, whatever it is that your business does, that can feed into a Kafka cluster. And then you can see here at the top, you can use things like Apache Spark and Apache Storm to do that processing, transformation, graph analysis, right? So Kafka essentially becomes your pipeline, and it becomes like your glue almost that puts together different parts of your overall big data architecture. Okay. All right, let's move swiftly on since I don't want to run out of time and switch gears a little bit and talk about Apache Zeppelin. Now, this is one of my favorite projects, even though it's not technically a big data project. It is essentially a web notebook like Jupyter. I think everyone's probably familiar with Jupyter notebooks already. Zeppelin is written in Java, and it's it's Apache Zeppelin, and it has plugins for virtually all of the different Apache big data projects and other things like Elastic and just straight JDBC and things like that too. But what is it, right? What you can do with Zeppelin, it's a web notebook. So it's really useful for doing experimentation and also for building out graphs from data which are already inside of, for example, a Spark cluster. So you can take this web notebook that you can run on your laptop, or you can run on a server somewhere. You can share that notebook with other people. And then, for example, you can connect to a Spark cluster, right? Whether it's a local one just for experimentation and testing, or an actual production Spark cluster that, I don't know, has 50 gigs of data stored inside of it, right? And it's a great way to kind of experiment and get going with these big data projects, or to build out like prototypes. You can also connect to JDBC to pull in something directly from a Postgres or whatever database that you like. And Zeppelin has different kernels. For example, you can write code in Scala, in Java, in Kotlin, and even in Python. Okay, so let's see what this looks like. So this is a Zeppelin notebook where we're pulling in data and showing it and visualizing it in a couple of different graphs, right? So let's go on to the next one. And if you look here, I know the font is a little small, but if you look here, what we're doing is we're actually writing code here to go, and in this case, we're not connecting to a Spark cluster or anything, but you can. We're pulling in some banking data in a CSV, and then you can see that we're going and doing some manipulation. We go and enclose that data into this bank object near the bottom, and then you can see that we're running two maps against it to go and manipulate that data. Okay, but I just want to give you an idea of how you could use Zeppelin to do some experimentation or to build out prototypes, and then you can take that code and put it into like a regular Java project, and then deploy that into a Spark cluster or whatever you need to do. Okay, and again, it's not just Spark. You can do JDBC, you can connect to Apache Storm, et cetera, et cetera. All right, so let's talk about something a little bit different now. This is a newer project called Apache PINOT. That's similar to something called Apache Druid, but what Apache PINOT is, it's a real-time distributed OLAP data store. And its key selling point is that it allows you to do OLAP queries at massive scale with very, very low latency. So if you're not familiar with the term OLAP, OLAP stands for online analytical processing. Okay, but let's see what some of the use cases for PINOT are. Okay, well, we'll get to that in just a second, right? With PINOT, we can do near real-time ingestion of data, for example, from Kafka and other sources, not just Kafka. It allows us to do low latency queries, and we can do SQL-like queries. Who uses Apache PINOT? So I believe PINOT actually came out of LinkedIn engineering. And so when you go to LinkedIn and you go click on the thing to see who viewed your profile, that query is coming from an underlying Apache PINOT cluster, right? So again, when you click on it, you see how fast it is, right? It comes up almost nearly instantaneously. So I'm sorry. So yeah, viewed my profile at LinkedIn. It can also be used for anomaly detection. For example, for like credit card fraud, right? Is this person's purchase does it fit into what their profile of their spending habits or where they would normally go or whatever look like, right? And if you've ever used a credit card before, which of course everyone in this room has, you know that when your card gets rejected, it doesn't take, minutes. It happens within a few seconds that your credit card is either accepted or rejected. So again, something that is currently used, that one use case for PINOT. And then of course, you've also heard of Uber Eats. They have a restaurant analytics dashboard that is built on top of PINOT. Okay, so there's some use cases. And again, this is a project which is relatively new compared to the other ones. It's been around for years and years. But the oldest project, I think that would fit into the big data category at Apache is Cassandra. And Cassandra came out of Facebook, but that was way back in 2008, right? All right. So again, here's a nice graph. You can go to the URL at the bottom to get more info on what these folks specifically offer. They offer a hosted solution for Apache PINOT. They're called startree.ai. But we talked about some of these things already. User-facing apps, that's like the LinkedIn, anomaly detection, operational analytics, et cetera, et cetera. I gave some examples already, so I won't rehash that, right? But I think that the thing that's on the bottom left is the important part, right? We're talking about big data here. So millions of events a second, but we're still able to get near real-time analytics and queries out of the system. It basically uses sharding and automatic cluster scaling, well, not cluster scaling, but automatically partitioning of data, et cetera, to get that level of response time to get really, really fast results. All right. So let's get a little bit more hardcore into some big data projects. Now, Apache Beam has been around for a while. And this is one that a lot of people aren't familiar with because this is kind of in my opinion, a little bit of a lower level tool compared to something like PINOT or even Spark for that matter. It's meant to build your own big data platform on top of, Okay, so it gives you like the tools that you need to do it. But what Beam stands for is it stands for batch and stream. So I'm sure everybody in this room has worked on a project where you have to do batch processing, right? And what Apache Beam allows you to do is define and execute data processing pipelines. Right? So let's see what that means. Well, what are some of the use cases first? ETL, right? Everyone has probably heard of ETL or even done it. We already talked about how Beam can be used for building out batch processing as well as stream processing. But let's have a look at this in a diagram, because I think this is where it gets interesting. And so you can see Apache Beam is kind of in the middle there. You write the batch processing and stream processing. You can write in several different languages, not just Java. We have Python, Java, and Go here. And you basically build out these pipelines, which are, again, built with Apache Beam tools, and it outputs something that you then take and feed into something like a Spark runner that can go and execute that after you've done that initial batch processing. Or you can have a direct runner, which may or may not be single threaded. And then there's something called data flow, which Google's Airflow big data hosted product is built on, right? So Google has something very similar to this, to Apache data flow, which is they call Airflow. And it's almost like a visual way of building out these batch and processing pipelines, okay? So let's see what this actually looks like. And this is, again, a word count example. It's a little bit more complicated than what we saw in the Spark instance, but this is how you essentially build out a pipeline with Beam. You say, go and read from a file on the third line, do a flat map to convert every, to split every word by a space. I won't explain the rest of it. You can read it and you can see it's pretty straightforward, right? Convert everything to lowercase, get rid of the punctuations. Is it a stop word? And then go count each one, right? So this is building out a pipeline that allows you to do this. And then you put this into a Beam runtime and it will go and execute it for you. Okay, and I mentioned Apache Airflow before. Google has something similar, and it uses basically a DAG of different tasks. So once your batch processing is not simple like what we just saw, and you have different types of batch processing or stream processing you need to do, you can use a DAG that will allow you to essentially snap together different types of things that you need to do to go and process your data. Okay. All right. There's a ton more to explore here. Obviously, we didn't even get a chance to talk about, for example, Apache Storm, which is another kind of low-level tool for doing big data processing. We didn't talk about Flink or any of those other ones. But I just want to give you an idea of some of the things that are there, some of the things that I've found interesting as I've worked on big data projects over the years.